Hi Calc Kids! Welcome to the last new stuff I'm going to teach you. This is lesson 10.2. Okay, this is where we're actually going to talk about the washer method, but we're going to rotate it about a shifted axis. So that means no longer the X or Y axis, and that's what makes this one different. Okay, so make sure you understand that what we're looking at today is not the X or Y axis. Okay, it's a axis that has been shifted, so it's no longer on the X or Y axis. Please, the reason that's important is because when you are on the X axis, so like down here, your Y value equals 0. When you're rotating about the Y axis, your X equals 0. So that point that it's a 0 is really kind of important, and we kind of looked at that that number 0 previously, so we're going to see how that changes. So our equation for the washer method is still the same. That's not going to change. Okay, r of x is going to be the radius to the outer curve, and the little r of x is going to be the radius to the inner curve. Okay, so on this first, just looking at this, we're not going to solve these ones, we're just going to talk about them. Okay. So if we have y equals the square root of x, okay, so that is going to be this graph right here, the square root of x, and y equals x squared, this is the x squared, the blue one, okay, and we're going to rotate it about the axis y equals 0. So that's this dark line I put here, and then I drew my little rotation so you know. We're not rotating about the x-axis, we're not rotating about the y-axis, we're going to rotate it about this. Now, because it's a horizontal rotation, this means we use the x's, okay? If it was a vertical rotation, remember that would mean that we need to use y's, which means we'd have to change our equation. So we'll look at that later, okay? When we are finding r of x, big R of x, remember this is the radius to the outside curve, okay? So from the axis in which you're rotating it to the outside curve. So that means from here all the way to here. This is what r of x equals, okay? Before, we just took whatever this function was and we said this minus 0 because we were rotating it about the axis that had a value of 0. So what we need to do is we actually need to say, well, what is this distance? Because this distance is not this function right here. This function, x squared, is actually this distance. Okay? So it's actually that little piece right, sorry, my hand was in the way. This little piece right here is x squared. So we need to figure out what is this piece. Well, the question is, how do we do that? And it's a lot simpler than what you think, because we know that this whole distance right here, from here to here, is 1. Okay? Because this is y equals 1, so that means the distance from 0 to 1 is 1. So that vertical distance here. So if I want to find out this, which is my r of x, I can simply take this whole distance and subtract the piece that we know. So in this case, r of x is going to be 1 minus x squared. And then that is what we plug in to here, and we square it. Okay? When we're finding little r of x, remember this is for the inside function, the radius to the inside function, so from where we're rotating to the inside function, so that's this. Now remember, this function is the square root of x, but that is actually representing this distance down here. Well, again, if we know that this total height here is a 1, I can find this little r of x, the radius to the inside curve, by doing 1 minus the square root of x. So we're taking this whole thing, subtracting out this piece, and that's going to give us this distance. All right, so that is the piece that we would plug in here and square it. Okay, so that's the difference, is finding these two pieces. Everything else about this is exactly the same as the washer method that we did in the previous lesson. Okay, so let's go ahead and let's look at this first example. Okay, I'm using the exact same two examples that we did on the previous lesson, just so the curves and the functions and that rotation, what that looks like, are similar, or they're familiar to us. Okay, but we're just going to shift where we're rotating it about. So the first one here, we have 4 minus x squared divided by 4. So if we remember, this is going to give us this function right here. It's a quadratic. This is a 4. This is a negative 4. This is a positive 4. Okay, just rough sketching it since we sketched it in the previous one. Okay, then we also need y equals 2. Well, here's 2. Okay, this is y equals 2. All right, so this is the section that we are going to rotate about the axis y equals 5. Well, if this is where y is 4, y equals 5 is going to be up here. So that means I'll go ahead and draw this. I'm going to draw it a little bit thicker just so you guys see. This is what we're going to rotate about. Now, remember, this is a horizontal rotation, so that means we're going to use x's. Okay, so that means everything that we do needs to be in terms of x. Well, our equations are already in terms of x because they say y equals. So that means the other part that we have to make sure we use when we talk about the x's is our lower and upper limit need to be the x's. So that means we need to know the smallest x to the biggest x that this shaded area is using. So we did that in the last one where we found that this was at the x value of negative 2.8 and this was at the x value of positive 2.8. I know my graph is not very scaled to show that, but you can find that intersection. So that means this is going to be our lower limit and that's going to be our upper limit. Okay, now what we need to talk about is if we're going to rotate it about this, that just means that what we're going to eventually have is this shaded piece because it's rotating. So it's going to fall all the way up there and it's going to be something-ish like this. Okay, so we're going to see this. So the outside will be nice and solid, nice flat, I should say, all the way around, kind of like a can of green beans or something, but the inside of that can is actually gonna, like, I don't know how to show you guys, it's gonna like do that inside curve. Okay, so just kind of getting a visual, it's gonna have a completely open middle. Okay, but the outside is gonna be nice and flat. Now, when we're talking about r of x and little r of x. Okay, remember, this is the radius to the outside. So from where we rotate to the outside. Now, that's this line right here. Okay, that means this piece is my capital R of x. But I know that this distance right here is 2. Okay, because that went from the axis, which is a value of 0, to 2. Now, we do know this whole thing because this is the line y equals 5. So this is really going to be that whole distance of 5 minus what we know, which is 2, which is going to give us that 3. Now, we could have counted this was 3 because that's a nice horizontal line, but I wanted to show you that process so you're making sure you're okay with that. Okay, now, little r of x, remember this is to the inside function, so I'll do this over on this side. So this little piece right here is little r of x. Okay, well, we know that this whole piece is this function right here. Okay, and we know that the whole distance is 5 to where we're rotating it. So if I subtract this piece that we know, we can get the piece that we're looking for. So, sorry, I don't know why I wrote an equal sign. So 5 minus 4 minus x squared divided by 4. Now, you could leave it like that when you type it into the calculator, but that's just more pieces that you have to type in the calculator, so I would go ahead and simplify this. So distribute your 4. All right, we're going to get 5 minus 4 plus x squared over 4, which is just going to give us a 1 plus x squared over 4. So this is what we're going to be using as little r of x. All right, now we're just going to plug everything into our equation. So the volume is pi times our lower x, so the smallest x of our shaded area, which was negative 2.8, to the biggest x of our shaded area, which is positive 2.8, and then we're going to put in these. So my r of x, my capital R of x, squared minus my lowercase r of x, so my little r of x, 1 plus x squared over 4 squared. And this is all with respect to x. Okay, so let's go ahead. I'll type that one in real quick for you guys. So this is pi negative 2.8 to 2.8. Okay, parenthesis 3 squared minus 1 plus x squared divided by 4. I had to close 2 sets of parentheses there. Make sure you got that. Okay, because this first parenthesis is for this fraction that I typed in. That second parenthesis is for this whole piece that we're squaring. Then with respect to x, and we're going to get that the volume is approximately 104.238. Okay. All right. I'm going to pause here because I have a feeling that the next problem is going to take me a little bit longer. So I'll jump to the next video.